Welcome to this session. Here is a problem for us to solve. So show that the point 24 lies on the curve x cubed plus y cubed minus 9xy equals to 0. Then find the tangent and normal to the curve there. So that means we find the equation of the tangent and normal line at the point 24 on the curve. For the first part of the question, to show that the point 24 lies on the curve is just to show that when you substitute the values 2 for x and 4 for y, then the equation is satisfied. So solution. So replacing x for 2 and y for 4, we have 2 cubed plus 4 cubed minus 9 times 2 times 4. So let's see if this is 0. So this will give us 2 cubed is 8, 4 cubed is it 64? 64. 9 times 2 times 4 is 72. And 8 plus 64 is 72. And 72 minus 72 is 0. So left hand side is the same as right hand side equals to 0. Hence 2, 4 lies on the curve x cubed plus y cubed minus 9xy equals to 0. So that's part 1 done. Now to find the equation of the tangent and normal at this point 24, first we have to get the gradient function of this curve. So we do that one by implicit differentiation. So first step, supply d dx on each term. So d dx of x cubed plus d dx y cubed minus 9 d dx 9xy equals to d dx of 0. Now by power rule here we get 3x squared. By power rule you get 3y squared. But because we have a y, you attach dy dx to that term. This we can write minus 9d dx of xy equals to 0. Derivative of a constant is 0. Now here is a product of two functions. So you let this one to be u, let this one to be v. So we need u prime v minus plus v prime u. So we'll have 3x squared plus 3y squared dy dx minus 9. So u prime d dx of x is 1 times y, you get y, plus v prime differentiating y with respect to x. So this one will be 1 times dy dx, and then multiplied by u, which is x. So we have x dy dx equals to 0. In fact, we can divide through by 3 because every term has a factor 3. So that we have x squared plus y squared dy dx minus 3y plus x dy dx equals to 0. So we have x squared plus y squared dy dx open brackets minus 3y minus 3x dy dx equals to 0. Now collecting terms with dy dx, we have y squared minus 3x dy dx equals to, take these other terms to the right, 3y minus x squared. And then to make dy dx the subject, we divide through by that factor y squared minus 3x. So this and this cancels out, so that we have dy dx is equals to 3y minus x squared divided by y squared minus 3x. So derivative at the point 24, dy dx at 24 means where there's x put 2, where there's y put 4. So 3 times 4 minus 2 squared over 4 squared minus 3 times 2. So that will give us 12 minus 4 divided by, this is 16 minus 6, which is 8 over 10, and this is 4 over 5. So remember, the equation, the slope of the curve at the point of tangency is the same as the slope of the tangent line. So this means, therefore, the slope of tangent at 2, 4 is equals to 4 over 5. Let's call this one M1. So equation of the tangent is given by y minus f of x naught equals to m x minus x naught. So where this is our x naught, this is our value of f naught. So when x is 2, y is 4, so we'll have y minus 4 equals to m, which is 4 over 5, into x minus 2, and y equals to 4 over 5x minus 8 over 5, now plus 4. So minus 8 over 5 plus 4 gives you 12 over 5. So y equals to 4 over 5 x minus plus 12 over 5. So this is the equation of the tangent. Now, we know that if this is a tangent, then normal, so assuming that I have an arbitrary curve, then normal is a line which is perpendicular to the tangent. So this should be drawn here. So this will be the normal. So if M1 for this one is 4 over 5, then this, let it have the gradient M2. So M1 times M2 should give us -1. This condition for slopes of perpendicular lines. So 4 over 5 times M2 equals -1. M2 will be -5 over 4. So equation of the normal will be y minus f at 2 equals to M2 into x minus 2. So we have y minus 4 equals to -5 over 4 into x minus 2. Then we simplify this. So y equals to -5 over 4 x. This will be plus 10 over 4 plus 4. So y equals to -5 over 4 x. 10 divided by 4 plus 4 gives 13 over 2. So this is the equation of the normal. So that's how we solve that problem. Thank you.